In this video, we'll look at how you integrate when trig functions are involved. So the beginnings of this are basically just to do all the derivative rules that we've done before in reverse. So for example, in the previous section, we learned that the derivative of sine x was cosine of x, and that the derivative of cosine x was sine x. So the integration versions are these. The integral of cosine x would be sine x. And here, the reason that this is the case is because I'm just thinking of the integral as being antiderivative. So if the derivative of sine is cosine, the antiderivative of cosine is sine. And then for integrals, of course, we need our obligatory plus c. And then this one here, the derivative cosine, is minus sine x. So the integral of sine x is actually minus cosine. And the way I'm going to think about why the minus is in the other spot is first to rewrite this as negative sine x with another negative out here. So the two negatives cancel, and so that's really just the same as what we started with. And then the integral of minus sine is cosine by what we said over there, and this minus, the one out front, stays put, so we get minus cos x, and then of course our plus c. Okay, so in class we'll talk about what some of the other trig functions look like. So for example, what the integral of tangent is actually a little interesting. But for now, let's just take a couple of simple examples. So the first one, let's say we've got 4 cos x and plus 9 sine x. And we want to take the derivative, or excuse me, the integral of this thing. So because it's a sum of two functions, I can just take two basic pieces like this and just integrate each one. And by what we did up above, the integral of cosine is sine, and so the integral of 4 cosine is 4 sine. And then the integral of 9 sine is negative 9 cos x, and so I could write this as 4 sine x minus 9 cos x plus c. Okay. Now, another thing that of course can happen is that functions that we've dealt with before could also get involved. So let's say, for example, we had something like t squared minus cos t. Again, I can split this one as t squared dt plus, or actually minus, integral of cos t dt. And it's minus because we had a minus in the original problem. Now, the second one here, the integral of cosine is sine, so we'll get a minus sine because of the minus that was already there. And then t squared, well, that's not a trig function, but we remember this. It's just t cubed over 3. And then, of course, our plus c. Okay, so what's next? In class, we'll look at what happens when u substitutions get involved, what happens with the other trig functions, and what happens when other functions are composed or in other ways algebraically put together with all of the trig functions. So by other functions I mean stuff like e to the x, log x, x to powers, square roots, and so on. Okay, so what happens when these things enter into the mix? And we'll look at some more the other trig functions, particularly tangent. That one's nice and interesting.